let y of n minus 0.5 y of n minus 1 is equal to x of n, where x of n is equal to 2 into 0.25 whole power n u of n, then y of minus 1 is equal to minus 2, then the zero input response of the system is asking zero input response. Zero input response means h of x of n is nothing but 0. We have to take the initial conditions. How should we take initial condition? Just apply Z transform here. Y of z minus 0.5 into z power minus 1 plus, let me take 0.5 into z power minus 1 into y of z minus y of minus 1 is equal to x of n is 0 na? 0. In place of y of minus 1, given that y of minus 1 is equal to 2, just substitute that value. Y of z, if I simplify na, 0.5 z inverse into y of z plus 0.5 into y of minus 1 is equal to 0. In place of y of 1 minus 1, put minus 2. Let's y of z, if I take common na, 1 minus 0.5 z inverse plus y of minus 1 minus 2 na, is nothing but minus 1. If I take this side na, it will get 1 minus 0.5 is nothing but 0.5 into nothing but 1. Okay, let me take y of z is nothing but 1 by 1 minus 0.5 z inverse, 1 by 1 minus 0.5 z inverse. Okay, have you, it is okay. What is this? Is nothing but 0.5 into whole power n into u of n. It's nothing but like this na. 0.5 is nothing but 1 by 2 na. 1 by 2 whole power n u of n. So option A is the correct answer. Option A is the correct answer. Okay. Yeah. The input output of discrete time LTI system are related to as this. Given that y of n minus 0.4 y of n minus 1 plus y of n minus 2 is equal to x of n, then is asking DC gain and also asking high frequency. Let me take high inverse for Z transform. Apply Z transform. Let me take here na. Y of z is equal to next y of z minus 0.4 z power minus 1 into y of z, okay, plus z power minus 2 into y of z is equal to x of z, If I apply na, I'll get this. Okay, take these values one side, y of z common by x of z is nothing but, take this transfer function of 1 by 1 minus 0.4 z minus 1 plus z power minus 2. See, this is the answer na. Okay, he's asking the DC gain. In place of z, put e power j omega 1 by, for your convenience purpose, e power j omega na, e power minus j omega plus e power minus j 2 omega. For low frequency nothing but DC gain na. For DC gain put omega equal to 0. If I put omega equal to 0 na, what I will get? Put omega equal to 0 na. Put omega equal to 0. 1 by 1 minus 0.4 plus 1 is nothing but 2 minus 0.4 is nothing but 1 by 1.6. 1 by 1.6 nothing but 10 by 16 is asking the value na, gain. 10 by 16 is nothing but 0.625. Okay, 0.625. We have got the DC gain. For high frequency na, what is omega? For high frequency, put omega equal to pi. In the equation, you will get this option. Just solve that. You will get option. Put in place of omega, put omega equal to pi and solve equation. You will get 1 by 2.4 is nothing but this value. Option B is the correct answer. Option A is the correct answer. Both the statements are correct answers. Okay. Let's go for next question. The sequence x of n is equal to 1 by 4 whole power n u of n. DTFT is x of e power j omega. Let y of e power j omega equal to x of e power minus j omega. Then the value of y of n at n equal to minus 2. See this. These two are in antisymmetry. Nothing but y of minus n is equal to x of n is given like this. Given y of n is equal to x of n. Y of minus n equal to x of n. See this. Okay. We know that x of n is equal to 1 by 4 na, 1 by 4 whole power n, u of n. You know this. In place of n, put minus n. See this equation. In place of n, put minus n. Okay, or else x of minus n. See this. If you know, in place of n, put n equal to minus n. 1 by 4 whole power minus n into u of minus n is nothing but 4 power n into u of minus n. Okay. He is asking at n is equal to minus 2 na. N is equal to minus 2 is a left side signal. It is satisfying. We'll get a value. Put n is equal to minus 2. 4 power minus 2 is nothing but 1 by 16. 1 by 16. So option B is the correct answer. Option B is the correct answer. Okay. Let's go for next question. The DTFT of x of n is equal to 2 sin pi n by pi n is x of e power j omega. Then the value of x of e power j pi by 2 is dash. Is asking now. We know that sine of omega c n by pi n into a is nothing but a Fourier transform na. Nothing but minus omega c2 plus omega c with the amplitude of a. Same this. If you compare these two equations now, what is omega c? Omega c is nothing but pi and a is nothing but 2. Just draw that. Minus pi 2 plus pi with the amplitude of 2. For this jet transform. Na. Okay. Where he is asking e power omega equal to pi by 2 na. He is asking at omega equal to pi by 2. If you place omega equal to pi by 2 na, if omega equal to pi by 2 will be getting here. What is omega equal to pi by 2 amplitude? It's 2. Answer is 2. Just simple question. This type of question is asked in our gate, one of the gate exam. Okay. Suppose the algebraic expression for the jet transform of x of n is x of z is equal to 1 minus 1 by 4 z power minus 2 plus 1 by 4 z power minus 2 into 1 plus 5 by 4 z power minus 1 plus 3 by 8 z power minus 2. The different ROCs could be correspond to the x of zr is asking now. For this, find the poles now. Poles will be minus j by 2 and plus j by 2. If you find poles for this now, you will get 3 by 4 comma minus 1 by 2. So 3 by 4 is from this side and this 1 by 2 is from this side. Minus 1 by 2. This is on the imaginary axis. Na? It will be on imaginary axis. Don't consider it. Okay. If a signal can be like this or can be like this. It's nothing but mod z less than 1 by 2 or mod z, this is 3 by 4 now, mod z greater than 3 by 4. Can be possible. These two ROCs can be possible. Mod z less than 1 by 2 is possible. Mod z greater than 3 by 2 is possible. Okay. Here also there will be possible for the ROC. Na? There is a possible for ROC here. From 1 by 2 to 3 by 4. 1 by 2 to 3 by 4. Okay. Also correct. Why haven't taken this now? Because there is a pole here now. If I take now for right side signal, we should be maximum. We have to take that pole. Which value is maximum now? We have to take that pole. If I take the signal right side now, which is maximum, 3 by 4 is maximum. So I have taken this. So I should not taken this. Okay. So option D is the correct wrong answer. So these three are correct statements. These three are correct statements. Okay. Okay. The jet transform of x of n is x of z. Then the jet transform of x conjugate of y. We know that x of n jet transform is x of z. X conjugate of n is nothing but x conjugate of z conjugate. That's it. X conjugate of z conjugate. So option A is the correct answer. This is the property type questions. Okay. Let's go for next question. System 1 is described by the y of n equal to 0.5 y of n minus 1 plus x of n. And system 2 is described by h of n is equal to delta of n minus 0.5 delta of n minus 1. If these two systems are connected in the cascaded, the output due to x of n is nothing but, just find from here x of h1 of n. Just find h1 is nothing but 1 by 1 minus 0.5 z inverse. If you apply your z transform now, you will get this h1 of n. What is h2 of n? Just like h2 of n is nothing but 1 minus 0.5 z power minus 1. Okay. He's saying that these two are connected in cascade. Na? Just multiply these two. Na? If I multiply these two, na, h1 of n into h2 of n is nothing but 1. 1. Na? Okay. From this, we can easily write y of n is equal to x of n. Na? Y of n is equal to x of n. Na? This z transform. If I apply z transform, na, these two are in cascade. Na? Cascade means cancel each other. X of n is equal to x of n is equal to y of n. From this we can conclude we can conclude y of n is equal to x of n na. Y of n, x of n value is this na. The same value will be for the y of n. Same value will be for the y of n. Okay. Okay. We'll go for next question. The consider the filter y of n is equal to 0.5 x of n plus x of minus n minus 1 plus 0.5 x of n minus 2. Then the response due to the input x of n is cos pi by 3 n. Okay. Let me do this. If I apply Z transform, just apply Z transform only. Y of z is equal to 0.5 x of z plus z power minus 1 into x of z plus z power minus 2 into x of z. If you take all one side, na, x of z is equal by y of z nothing but y of z by x of z is nothing but 0.5 plus z power minus 1 plus z power minus 2. Convert to exponential term 0.5 plus e power minus j omega plus e power minus j 2 omega. In place of omega, put omega equal to pi by 3. Just put omega equal to pi by 3. 0.5 plus c is a 0.5 na, so 0.5 na, 0.5. Put this 0.5 is nothing but 1 by 2. Okay. Just put omega equal to pi by 3 in the above equation. If you put omega equal to pi by 3 na, you will get shifted by the pi by 3 signal. It will be shifted by pi by 3 e power minus j into omega equal to pi by 3 plus 1 by 2 e power minus j into 2 into omega equal to pi by 3. If you solve this for magnitude na, what is the magnitude you will get? Is nothing but 1.5 magnitude you will get na. What is 1.5 into cos of n pi by 3 minus pi by 3? So option B is the correct answer. If you solve this, find the magnitude, you will get the answer. Okay, find the magnitude. Okay, let's go for next question. The value of minus pi to pi 4 by 1 minus 1 by 3 e power minus j omega whole square d omega. Okay, just take this omega na. In place of ohm, you take its omega. You will be understanding. Okay, how you solve now? We know that Parcell's equation n is equal to minus infinity to plus infinity. X of n modulus whole square is nothing but 1 by 2 pi minus pi to pi x of omega whole square into d of omega. Okay, just look at this equation and this equation, both are same now. Just set 1 by 2 pi is the extra term now. If you multiply this side, 2 pi into summation n is equal to minus infinity to plus infinity modulus of x of n whole square. Okay, what is x of n now? X of n is nothing but, for this, 2 by 1 minus 1 by j e power minus j omega. If I take whole square as common, whole square inside value is nothing but 2 into 1 by 3 whole power n into u of n. See this, substitute here, 2 into 1 by 3 whole power n into whole square into u of n is nothing but 0 to infinity. From 0 to infinity, summation 0 to infinity. Just apply summation n is equal to 0 to infinity, 0 to u of n is 0 to infinity into 2 pi. If you multiply this na, you will get, if you solve this, you will get 9 pi. If you solve this, you will get 9 pi. So option C is the correct answer. Option C is the correct answer. Okay. The inverse Fourier transform of the spectrum shown in the below. This is given. For this, if I take this now, this is 1. This one, Fourier transform is 1. Okay. For this, I know that rect f. What is rect f? Minus 0.5 to 0.5. Minus 0.5 to 0.5. You know this. Just if I shift the signal place 0.5 units na. If I shift the signal by 0.5 units na, I'll get this 0 to 0.5 na. 0 to 0.5 the amplitude of 1. This is rect of f minus 0.5. Okay. If you subtract these two na, you will get this signal. If you subtract na, you will get this signal. What is inverse Fourier transform of 1? Is nothing but delta of t. What is rect t? Inverse Fourier transform is nothing but, rect t. Rect f inverse Fourier transform is nothing but sinc f. Sinc t. Rect f inverse Fourier transform is nothing but sinc t. Sinc t into shifted by signal 0.5 na will be exponentially minus j j 0.5 into pi by 2 into pi into t. Okay, into 2 pi t. Okay, see this. 0.5 into 2 is nothing but cancel each other, e power minus j pi t. Delta of t minus sinc t e power j pi t. So option B is the correct answer. Option B is the correct answer. Okay.